Welcome to my vlog on the SAP Data Hub. In it, I will show you the components the SAP Data Hub is comprised of, as well as its data processing capabilities. As this architecture diagram shows you, the SAP Data Hub is mostly comprised of three components. One is the SAP Data Hub application that is running on an SAP HANA Extended Application Services Advanced Application Server. Second comes the Hadoop cluster that hosts the Data Hub adapter and the Vora Spark extensions. And thirdly, a Kubernetes cluster where the SAP Data Hub distributed runtime runs on. Let's start with the SAP HANA server. That is what the server looks like. It is comprised of two so-called tenants, a system tenant and an application tenant, where the Data Hub cockpit has been deployed to. Here you can see that the Data Hub cockpit mainly comprises of 6 components plus a 7th component, which is the SAP Web IDE. So what does it in fact look like? The SAP cockpit gives you an overview of your SAP Data Hub operations. It shows you the systems you are connected to, the actual connections, in this case, an Hadoop file system, a Vora catalog, and a Vora data pipeline. It also shows you the objects you've been modeled, the task workflows and the data pipelines that had been running lately, and the items you have been discovered. We get into more of these details later. So secondly, we have the Hadoop cluster. And this Hadoop cluster has been set up and managed by Ambari. This comes with all the components of which we have some already seen, the Hadoop file system, Yarn, Spark and Spark 2, but also Kafka, which we will see in a second. And thirdly, there's the Kubernetes cluster, potentially the most complex of all of the components. In my case, this runs on a SUSE container as a platform environment consisting of 3 nodes. We have here the admin node, and then we have a worker and a master node. From a Kubernetes perspective, these are the 2 nodes. The admin node doesn't show up, and all the pods the application consists of, and we'll see this in a second in more detail. So what does it look like in detail? This is one of the SAP Data Hub pipelines I've been modeling. It uses a Kafka consumer. It has subscribed to a topic where one of my Raspberry Pis every minute sends data temperature information to this Kafka channel, and this data pipeline subscribes to it, and it writes it into a Vora table and also outputs it onto a terminal. So as you have seen, it's just 3 o'clock in the afternoon here, and another data item has been published. But if I look into the SAP Vora tools, I see all the data that has been posted into this for about a couple of days. Now, what do I do with this? The interesting thing here is that I can run those data pipelines out of task workflows that we have seen here in the overview, and here's one example of that. So we see the 2 destinations, 2 data sets, 2 tasks, and 1 task workflow, and that is in fact the task workflow. So it copies a file in the Hadoop cluster, and then it executes a data pipeline and finishes there. So what I can do here is I activate it in case of any changes. Here, see all my components activated, and then I run my workflow. Perhaps first I go into my data pipeline and make sure that I have the latest pipeline here attached. And I activate this. And with that, I can run my task workflow. So a task workflow is created. And if I look here into my cockpit and I refresh this, I see that I have a running task workflow now. I had already had a running data pipeline, which was my Kafka pipeline. But if I refresh this again, I see that my task workflow has started another data pipeline. And if I refresh this again, the data pipeline as well as the task workflow have successfully finished. And if I look into my pipelines here, this has been auto-generated. So this data pipeline has been executed, copying in an Hadoop file system. Excellent. One other important capability, data processing capability of the Data Hub is data discovery and data profiling. So when I go to the systems I've been connecting, I have the catalog, Evora catalog, where I have all my Raspberry data. And I can, of course, preview this and I see all my temperature information. But also I can look into my Hadoop cluster, and here I have a CSV file that I've been using for agile data preparation blog on the SAP community network, and this has been profiled, and I can look into the fact sheet as a result of this. And I can, for example, see, by country code, Premier League, which country had the most goals in the Premier League. Very interestingly, this is not a static profiling algorithm, but in fact, that's where it got profiled. It created a data pipeline for this. So you can imagine how powerful this could be if you put in, your own data pipeline for profiling. There's basically no limit to it. And especially in terms of big data profiling, if I look into the Kubernetes cluster again, there had been a pod created to do this profiling. So this could be parallelized in a basically unlimited way on your Kubernetes cluster. With that, I would like to thank you for your attention and hopefully see you soon with my next blog. Bye.